Dear students, video 1 comprises with unit 1 lecture of computer organization and architecture, that is lecture on Boolean algebra. In this lecture, I am going to cover the following point. At the beginning, what do you mean by Boolean algebra? After that, what is meant by Boolean function? Afterwards, we will be discussing and or not operations, that is logic operation. After that, we will be discussing what is the purpose of Boolean algebra. After that, in this video, we will be discussing various basic identities of Boolean algebra, and one example will be shared. The questions are given for your further studies. Dear students, let's see what do you mean by Boolean algebra. In fact, Boolean algebra is a branch of mathematics. It is an algebra that deals with the binary variables. Binary variables, these are the variables are having either value 1 or 0, nothing else. And there are certain logical operations. These binary variables are designated by by the letters such as small a, capital B, small x, small y. Now let us see what do you mean by various basic operations. There are three basic logic operations which we are going to study today, that is OR gate, AND gate and inverter, or to which we can say complement, or sometimes we can say it is a NOT gate. Dear students, you must be knowing a Boolean function can be expressed algebraically with various binary variables and the logic operation symbols. These are enclosed with certain parentheses and we can use to represent the expression the equal sign. Now let us see the new terminology that is called as Boolean function. What do you mean by Boolean function? Basically, Boolean function can be expressed algebraically with binary variables. Then the logic operations, certain symbols, parentheses, and equal sign just now I stated. Now, for a given value of the variables, the full Boolean function will have either one value or zero value. Means other than 1 or 0, there won't be any value for any given Boolean function. Now consider the example of the Boolean function. Suppose capital F is equal to x plus y complement z. This function becomes 1, or this function has got value f is equal to 1 only either x is equal to 1 or z is equal to 1 and y complement is equal to 0. Y complement is equal to 1. Otherwise, in all cases, the function f is equal to 0. The relationship between a function and its binary variables can be represented in a truth table. Now, what is the purpose of truth table? In fact, truth table, it is a table which we draw, which has got columns, which has got rule. But these columns are labeled with certain, say, variables. These are having certain purpose, and in each cell, that is row has certain values. That values must be either 1 or 0 in this Boolean algebra, and these columns and these cells are having certain relationship. So this relationship of the Boolean function is represented by the truth table. Now let us see the truth table. Here the relationship between a function and its binary variables can be represented in terms of truth table. To represent a function in a truth table, we need a list of the 2 raised to n combinations of these binary variables. Means suppose you have got 2 raised to 2. For example, there are 2 raised to 2. Then combinations means 2 raised to 2 is equal to 4. So there must be 4 rows. Now consider this particular figure of truth table where x, y, z, these are the binary variables, whereas f is its output. Means for a Boolean function f is equal to x plus y complement z, the output will be labeled by the column f as a letter or variable given. X is one of the column that is called as input, y is another variable, another column called as input, and z is another input. But in expression calculation, we take the complement, means reverse value of y, and it will be ANDed with Z. So here f is equal to x or y complement and z. OR gate is representing addition operation. Complement is represented with inverter gate or NOT gate, whereas AND gate represents the multiplication like y complement and z. These are the usage of AND or NOT gate. So I repeat, OR gate represent addition operation, binary addition, AND gate represent binary multiplication, and NOT complement or inversion is represented by NOT gate. Now, dear students, a Boolean function can be transformed from an algebraic expression into a logical diagram which comprises with and or and NOT gate, that is called as inverter gate. Now, let us see what do you mean by logic diagram. Logic diagram, it is a pictorial representation between input variables and its output with the help of various logic gates and the wires. So in this diagram, you will see that there are three inputs, X, Y, Z, and there is one output that is called as F. And this X plus is represented as X, and the X is one of the input of last OR gate, that is that represents the addition. Then AND gate has got two inputs. One is Y inverter, means not Y complement, and Z. Then Y complement and Z means Y complement dot Z, which is another input of say OR gate, and finally F is equal to X plus Y complement into Z. This picture is called as a logic diagram, which is displayed in diagram B. Now let us see what is the purpose of Boolean algebra. Basically, Boolean algebra, the purpose of Boolean algebra is to facilitate the analysis and design of the digital circuit. Means Boolean algebra gives a facility which helps in analyzing the various difficult, complicated, very large digital circuit, and after that analysis, it comes to a simpler form which is able to be designed by the electronics or hardware engineer. Now, how this particular tool becomes a convenient for us? This convenience is provided in three ways. One is it express or it is useful to express in algebraic form a truth table relationship between the binary variables. Means what is the relationship between various binary variables is expressed in terms of algebraic form, which is useful to analyze the given circuit. Number two, this tool is convenient to express in algebraic form the input and output relationship of logic diagram. Means in previous case we have studied X, Y, Z, these are the inputs, and output is F. So what is the relation between F and this input variables X, Y, Z? It is algebraically expressed with the help of this particular tool. That's what it is one more, or it is one of the convenience provided by this convenient tool called as a Boolean algebra. And third, it is useful to find similar circuits for the same function. Means for this particular same function we can come to a state where a simpler form we can get in the form of Boolean function, and from that Boolean function we can go for designing of say simpler electronic circuit. Now let us see what is the basic concept of basic identities. A Boolean function is specified by a truth table and which can be expressed algebraically in many different ways. Means a single Boolean function can be represented in a multiple way. Now, how this can be done? Let us see. We must first study and manipulate what are the capabilities provided by the Boolean algebra. Means here in the next slide we are going to study the capabilities provided by the Boolean algebra in order to manipulate its strengths. So next table, table 1.1 list the most basic identities of Boolean algebra. So there are two columns. In first column you will see that there are all OR operations, addition operations. And in second column you will see that there are identities which are most related to AND operations or binary say AND. So in rule number 1, x plus 0 is equal to x. Rule number 2, x and 0 is equal to x. Rule number 3, basic identity number 3, or Boolean algebra rule number 3, x plus 1 is always 1, x into 1 is equal to x plus x is equal to x into x is equal to x. Rule number 7, x plus x complement is equal to 1. Rule number 8, x into x and x complement is equal to 0. Rule number 9, x addition or x or y is equal to y plus x. In mathematics, these particular rules are named with certain another convention, but we are going to focusing on this here for the digital circuit simplification. Then rule number 10, xy is equal to yx. Rule number 11, x plus in the bracket y plus z is equal to in the first bracket x plus y bracket complete plus z. Rule number 12 or basic identity number 12, it is x in the bracket y and z bracket complete, which is equal to x and y bracket complete and z, and means into. Rule number 13, x in the bracket y plus z, which is equivalent to xy plus xz. And rule number 14, x plus yx, which is equal to x plus y in another bracket x plus z. Rule number 15, x plus y bracket inversion or complement, which is equal to x complement and y complement. And rule number 16, xy complement is equal to x complement plus y complement. And last, complement of complement, which is equal to main element, that is x complement bracket complement, which is equal to x. So dear students, these basic identities are useful for simplification of any given Boolean function which is complicated in nature. And when we can apply this particular rule and we can go on step by step making simplification, and we can come to a smaller expression where there are very few operations and where there are very few variables, then this particular circuit design helps you in a smaller size. Now consider as an illustration, I'm going to discuss one of the example. Consider the following Boolean algebra expression, that is f is equal to ab complement plus c complement d plus ab complement plus c complement d. Now here if we can observe this particular Boolean expression, then we can come to know that there is a common thing, that is ab complement plus c complement d, to which we can say x is equal to ab complement plus c complement d. Then if we can write x plus f is equal to x plus x, but go back to the table, that is x rule number 5, that is x plus x is equal to what? X. So by using this particular identity, this particular complicated expression where there are 1 2 3 4 5 6 7 8 variables, and there are there are 3 binary addition operations, and there are 4 inversion operations, and there are 4 binary multiplication operations. This can be reduced to a simpler and say a simple version of this particular expression in the simpler form, that is nu f ab complement plus c complement d plus a complement b plus a complement c complement d, which is the original, which comes to the simpler version, that is x. And as we know, x is equal to ab complement plus c complement d. This is what we can go for from say difficult expression, complicated expression, such a large expression, to a very simple form where there is one binary OR operation, binary addition operation, there are 2 binary inversion operation, and there are 2 binary multiplication operation or AND operation. Dear students, I'm going to give one of the question number 1. Simplify the following Boolean expressions, which is by using the various basic identities of Boolean algebra. Number one, a plus ab. Number two, ab plus ab complement. Number three, a complement bc plus ac. Number four, a complement b plus abc complement plus abc. And question number two, write the importance of Boolean algebra in digital circuit. Dear students, for any question or query, you can call me on 9881 677 445. Thank you.